Question is, can you think of two numbers whose sum is 4 and whose difference is 2? All right, so, I mean, it seems like a yes or no question, so I suppose if you wanted to really answer, you could just say yes or no. But let's actually think of those numbers. So give me just a pair of values. 3 and 1. 3 and 1. All right, that'll get the job done because 3 plus 1 is equal to 4. 3 minus 1 is equal to 2. All right. So now they're saying, given that y is greater than x, write two linear equations to express this situation from above. All right. So y is greater than x is implying that x and y are the two numbers. All right. So the fact of the matter is we don't have to actually state let x equal this, let y equals that, because they've already given that to us. So x and y have to add to equal 4. And if y is greater than x, when we subtract them, y has to be the first value in order to give the result of 2. Now, they're telling us to graph these two equations. It says using the two linear equations you created from question 2, graph each equation on the coordinate plane provided. And then what's the solution? And there's a couple of ways to graph linear equations. I'll rewrite them down here and I'll show you probably a way that not too many people would have gone about doing it, but it's actually pretty easy when your equation is given in the form that it's given. Except I'm going to write the second equation as negative x plus y equals 2, just to have it consistent with the form of the first equation. All right. What's an x-intercept? Conceptually.
When the line crosses the x.
When the line crosses the x-axis. All right. Does anybody know how to find the x-intercept on a graph? Well, what do we know about the y value if a point is on the on the x-axis? What does y have to be?
0.
0. All right. So what we can do here is actually very quickly and I think pretty easily figure out the x-intercepts just by replacing y with 0. All right. So x plus 0 is equal to 4. And you wouldn't even have to show this step because really it's just a matter of ignoring the y term. So I know I'm not really covering anything up, but on your paper just cover up the y. And what would you have? You'd have x equals 4. Right? That's your x-intercept. We could do the same thing with the other function. We would have negative x plus also 0 equals 2, in which case we'd have negative x equals 2, which means that x has to be equal to negative 2. All right. We could also find the y-intercepts. All right. Now, normally you'd have to put your equation in y equals mx plus b form in order to find the y-intercept. But if we use the same idea here, we can actually do it fairly quickly. All right. So if finding the x-intercept, we replace y with 0, what do you think we're going to do if I want to find the y-intercept?
Replace x.
Replace x with 0. So 0 plus y is equal to 4, making y equal to 4. And then negative 0, or just 0, plus y equals 2, so y equals 2. All right, so each one of these pairings is going to give you values that you can plot. Now, the whole idea is that you're not actually doing all this work algebraically. All right, so you might look at this and say, well, do I have to do it that way? Because that's the usual question I get. Do we have to do it this way? Sorry, it sounded like I was about to cry, but I was about to cough. Although, it does sound like people are about to cry when they ask that question. Do we have to do it this way? It's terrible. Because you want to solve for y in terms of x. You want to do it the way that you already know how to do it, right? The issue is, moving forward, we're going to have to find x and y intercepts for a bunch of different types of functions, right? Functions that I can go down the list and name them all now, but it would be pointless because I would just be naming types of graphs just to sound impressive. All right, so there's no value in doing that at this point. All right, but I promise you, this concept, finding x and y intercepts, is going to be very, very useful to the point where you can use this as a universal, general truth rather than the y equals mx plus b, because y equals mx plus b only works for lines. Right? It's not going to work for, well, parabolas you should know about. The U-shaped curves, you've worked with those before, right? There's no y equals mx plus b for that, so you're going to have to use a strategy similar to this, right? So what do we do with this information? Well, for the first line, I have an x-intercept of 4 and a y-intercept of 4. So that means it crosses the x-axis at positive 4 and the y-axis at positive 4. All you need to draw a line are 2 points and a ruler. Now, some folks were asking me, I think it was on no, it couldn't have been Friday. Whatever the day was that we were doing independent work, whether you had to label your graphs. And my answer was, if the only thing that's on the graph is a single line, then no, because it's obvious what you're graphing. All right, but here we're about to graph 2 lines on the same set of coordinate axes. We need to distinguish one from another. All right, so x plus y equals 4. Now for the other one, I have an x-intercept at -2. So 2 units to the left of the origin, and a y-intercept at +2. Kinda. There we go. And this one was y minus x equals 2. All right, so very easy to create the graph by hand when you do it by intercept, right, for linear functions and also for other types of functions. Now, number 4 is asking us for the solution. When we're talking about a solution for a linear system, we're looking for the intersection between the 2 graphs. All right, so this has an intersection of 1, 3. Now, it's just asking us for the location of the intersection, but I also want to talk about the proper, well, yeah, I guess proper notation. So it's the squiggly bracket stuff. What we would say here is, well, a couple of ways you could write it, but we would say that the solution is xy such that x equals 1 and y equals 3. All right, so this is the set notation. But this, in this case, you could just write 1, 3. And that's only because it said where. It was asking you for a location on the graph, right? But we want to be prepared to write it in the proper notation, right? It's annoying, but it's something that you've kind of, or I was going to say you kind of got in the habit of doing, but maybe not. You're slowly, in some cases, getting into the habit of doing, with great resistance, but you're getting there, all right? So just going back to the statement here, system of equations, it sounds very fancy, but The system of equations is really just two or more equations on the same set of axes. All right, so two or more equations graphed on the same set of axes. Not necessarily graphed, but in this case, we're graphing them. All right, so that's all it means. Just because you have a system doesn't mean you're necessarily looking for the solution to the system. Let me show you a really kind of out there approach for doing or solving linear systems on your calculator. It's really not for everyone. It's very, very, very advanced. Not hard, but advanced. All right. Definitely not required knowledge. Definitely not an approach that anyone's going to ask you to do on the Regents, but it'll get you answers to questions like this very quickly, even ones that have funky numbers. So, I mean, how could that be a bad thing, right?